Hello friends, in this video I am going to talk about the next CPU scheduling algorithm, which is priority based scheduling. So priority based scheduling algorithm works on the priority assigned by the operating system to each and every process. So whenever a process is created, operating system assigns a number, we can call it as a priority number also, to every process. Now with this priority, OS decides whichever process has higher priority, that will be given the chance to execute the instructions in CPU. This algorithm can be implemented in both modes, preemptive as well as non-preemptive. To understand this algorithm, let me take this question. Here I have taken 7 processes whose priorities are given. And in the table it is mentioned that 12 is the highest priority you have to consider. Means higher the number, higher the priority you have to consider. Lower the number, lower the priority. Means here process P5 has the lowest priority, and in the increasing manner then 4, 5, 6, 10 and 12 being the highest priority here. Let me solve this question in both the modes, non-preemptive as well as preemptive way. Let's first draw the Gantt chart according to the non-preemptive architecture. So here at time t is equal to 0, I have process P1. At this moment I have only one process, so it will be scheduled to CPU. Now since this is non-preemptive architecture, I am considering here at time t is equal to 4, it will finish. And while it is doing the execution, no other process can preempt this running process P1. Even if some other higher priority process arrives in between 0 to 4, it cannot halt the execution of P1. So while it is doing the execution, at time t is equal to 1, P2 arrives. At time t is equal to 3, P3 arrives. And at time t is equal to 4, P4 arrives. Now at this moment 4, at time 4, we have 3 processes, that is P2, P3 and P4 competing for CPU. So we have to make the decision here. So let's look at the priorities of these processes now. P2's priority is 5, P3's priority is 6 and P4's priority is 10. So among these 5, 6 and 10 being the highest priority, I am going to schedule the process P4. It will take 3 time units as per the given chart. The burst time of P4 is 3 time units. So from 4 to 7 it will run and it will finish at 7. While it is running, at time t is equal to 5, process P5 arrives. At time t is equal to 6, process P6 arrives. And at 7, P7 arrives. Now at this moment, at time t7, P1 and P4 are already completed, and the decision I have to make among the processes P2, P3, P5, P6 and P7. Out of these 5 processes except P1 and P4, I can see that the P6 has the highest priority, which is 12. So here I am going to schedule the process P6. It will take 4 units of time as per the table given, and it will run up to 11, and at time 11 it is going to finish. At time 11 the next priority is priority 12 means of process P6 is completed. With priority 10 P4 has already completed. Now let's go for the next priority which is 6, that is a P3. So at time t is equal to 11, I am going to schedule the process P3, which is going to take 2 time units, and at time t is equal to 13, it is going to finish. Next priority is 5. So at time 13, I am going to schedule process P2. It will run up to 18. It takes 5 time units according to burst time, and it will finish at 18. Then according to table, I can see the priority 4 of the process P1. But it is already completed. So let's go for the next process, which is P7, whose priority is 4. So I'm going to schedule the process P7 now. It will take 3 time units and it will run up to 21. It will finish. And only one process is remaining, that is with the priority 3, which is the lowest one, the process P5. And it will finish at 27 as its burst time is 6. Let's solve the same numerical with the preemptive way now. Remember that in the preemptive architecture, when a process is under execution, we can halt its execution, means we can preempt that process and schedule any other process. So let me start with the process P1, which is arriving at time 0. So at time t is equal to 0, I have only one process, I am going to schedule it. While it is running, though it has not completed its execution, see, P1 wants total 4 units of time in CPU. But I have allocated only 1 here because at time t is equal to 1, process P2 is arriving and P2's priority is higher than the running process, which is P1. So P2's priority is 5. That's why the process P1 is going to preempt here and process P2 is going to schedule. Now from 1 to 3, the process P2 can run because in between 1 to 3, no other process is arriving. The next process arriving is at time t is equal to 3. And at time t is equal to 3, process P3 arrives with again higher priority, which is 6. So I am going to preempt the process P2 here and going to schedule the process P3. Again at time t is equal to 4, the higher priority process arrives with the priority 10. So P3 will get P3 will get preempted and P4 will get scheduled. At time 5, process P5 is arriving, but here the process P5's priority is lesser, which is 3, than the running process. Running process priority is 10. So at this moment, I don't have to preempt the process P4. It will continue the execution. Again at time t is equal to 6, one more process is arriving, P6, and P6 having the highest priority among all processes, no matter which process is running, that will get preempted and P6 will get scheduled. And we know that and as I said, process P6 has the highest priority, means even if it is running and some other process arrives, we cannot preempt the process P6. So while P6 is running, we know that at time t is equal to 7, process P7 is arriving. And P7 has the lower priority, so it has no effect on the execution of P6 and it will continue. So here the P7 process is the last process which is arriving, and once all processes arrives in the system, the preemptive algorithm behaves like the non-preemptive algorithm that we discussed earlier. Why so? Because after this point onward, no process is going to come in between, when some process is under execution. All processes has already arrived in the system so far, and that's how my decision making is purely based on priorities now. So at this point onward, I can simply arrange all processes in the increasing order of their priorities. Let me finish the process P6 now. So it will take 4 time units starting with 6. So 6 plus 4, that is 10. At time 10 it will finish, and at time 10 I will just arrange all processes in increasing priorities now. So process P4 has the priority 10, followed by process P3 priority 6, followed by process P2 which has priority 5, followed by process P1 which has priority 4. Now here I have allocated 3 time units to process P1. Why? Because one time unit we have already allocated, right? So you have to keep track. Once you allocate the time to any process, in the future you have to allocate the remaining time only. So then the next is process P1 whose P7 whose priority is 4, and at the last priority of process P5 is least, that is priority is 3, and that's how the all processes completes their execution. The priorities are of two types, static and dynamic priority. The meaning of the static is, once the process is created by OS, it assigns the priority and that priority never changes till its life, means till the process terminates. Whereas in the dynamic priority, the priority of a process may change over time. And how this is useful to a process? Let's say a priority assigned to a process is 3, which is lower than other processes. And this process, a particular process with lower priority has waited for a long duration of time, let's assume. Now what OS can do? OS can boost its priority to some other number, let's say 10, so that the chances of getting this process in the execution increases. We call this dynamic priority as aging algorithm also. Why this is a aging? As and when the age of the process increases, which has waited for a longer duration of time, OS can keep on boosting its priority. And that's how we complete the priority based scheduling. In the next video, I'll talk about one of the very important algorithm, which is round robin algorithm.